Hi everyone, welcome to Mr. Techpathy Tutorials. This is part 5 of Linux device drivers. Today we are going to discuss about building and compiling kernel modules. In this session, we'll discuss about 5 topics. First one, Linux device drivers, examples and references. Number 2, setting up environment for compiling kernel modules. Number 3, implementing a Hello World kernel module and discussing about the macros used in it. Number 4, creating a makefile to compile a Hello World kernel module. Number 5, compilation and kernel object generation of a Hello World kernel module. Before proceeding further, make sure that you have watched my earlier videos on Linux device drivers. Coming to our first topic, Linux device drivers, examples and references. As mentioned in my earlier sessions, most of the concepts discussed in these sessions are derived from a famous book from Orally series. The book is named as Orally Linux Device Drivers 3rd edition. To demonstrate kernel programming concepts, I'll be using the Orally sample programs which are available on below site to download. For your convenience, I have added this link to the description of this video. As a part of Linux references, download these files from the Orally official site mentioned in my description of this video and save it to your hard drive. Compiling, loading and modifying these examples are a good way to improve your understanding of Linux device drivers. Please note to use these example files at your own risk. All examples work with any 2.6.x kernel. You need to install kernel headers before building and running your modules. We'll discuss about installing kernel headers in coming slides. Our second topic is setting up environment for compiling a kernel module. Here, I am using a virtual Linux system in Windows 7. To know how to install Linux on Windows 7 PC, please watch my earlier video on installing Linux in Windows 7 PC using Oracle Virtual Machine. Now, I'll open a terminal. I'll go to Applications, Systems, and I will open a terminal. For setting up this environment, we need to install necessary package required for compiling kernel module. In order to install any package, you should be a super user. From here on, we'll address super user as a root. To log in as root, I'll type su command in this terminal and enter. Provide the necessary password. I'm giving my password here. So here I am as a super user. It's always safe and good practice to log in as a user and then switch to root whenever it's required. Now to install kernel headers and other basic packages for compiling the kernel modules, type this command yum install vim gcc kernel devel kernel headers dkms make and bzip2. So right now we are going to blindly install these packages. We'll be discussing about each and every package in coming slides. Discuss about the packages which we have installed using the m command. Coming to the m command, m is an interactive RPM based package manager. It can automatically perform system updates including dependency and analysis absolute processing based on repository metadata. Please refer the man page of yum to know more about yum install. Into the packages, vim is a popular Linux editor, gcc is a compiler, devel are the files that are required for compiling kernel code that will run as a part of the kernel such as kernel modules. Kernel headers, it contains the files that describe the system environment and are used for compiling normal programs that run in user space. DKMS is the dynamic kernel module support package. Make is a tool necessary for kernel code build system. bzip2 is a zipping tool. Few packages are necessary and few packages are mandatory for compiling your Linux kernel module. With this information, let's type the command and press enter. While installation, kernel may ask, is this OK, Y or N? Type Y and complete the installation. Since I have already installed all these packages, it may throw up error or it may say nothing to update. As you can see, it is saying that there is a duplicate package for GCC. There is no need to worry. You need to type this command and complete your installation. Once the installation is done, reboot your Linux machine. I'll reboot my virtual Linux machine by typing reboot command. Once your VirtualBox is rebooted, log in with your user credentials. I'm typing my password. We have completed our second topic, setting up environment for compiling the Linux kernel modules. Third topic is implementing a Hello World kernel module and to discuss about macros used in it. Now let's begin with a Hello World kernel module. I have already logged into my virtual machine as a user. I'll open a terminal. We'll go to the applications, system and terminal. You can even create a shortcut for yourself on the desktop. Just go to system tool terminal and drag it onto your desktop. Now I'll type pwd command to know the current path. So I'm in /home Mr. Tekpati. Let's create a directory using a makedir command. I'll name my directory as ldd3. Change the directory using the cd command. We'll create our first Hello World kernel module. For this, we'll use the Vim editor, which is very popular and used by many Linux developers all over the world. Now let's type our Hello World program. I'll name it as hello.c. So I'll type the command vim hello.c. Let's type the program. We'll start with the headers. Hash include linux/init.h. Hash include linux/module.h. We'll be using a special macro called module license. We'll be discussing more about these macros in coming slides. Here we are with the sample Hello World program. In orally examples, you can find this program under hello.c. Let's understand more about the Hello World kernel module. Coming to the Linux kernel header used in this sample program, hash include linux/init.h. This header contains the definition of the functions used in this module. Module init and module exit are defined in this file. Module init is a macro which defines the function to be called at module insertion time or at system boot time. Module exit is a macro which defines the function to be called at the module removal time. This function is also called cleanup function. Kernel modules must always contain these two functions, init module and cleanup module. The second header used in this kernel module is hash include linux/module.h. This header is included to add support for dynamic loading of the module in the kernel. It also contains the definition of the special macros used in this module. Special macros like module_license is defined in this header. Coming back to our program, now we have seen what is the significance of the kernel headers included in this kernel module. Let's discuss about the macros used in these functions. You can see that macros used in these functions are module license, printk, and kernel print. So let's discuss them one by one. Module license. Module license is a macro used to tell the kernel that this kernel module bears a free license. Without such a declaration, the kernel complains when the module is loaded. Coming to the printk function, this function is similar to printf in standard C. This is implemented to make kernel have its own print function instead of having dependency on C library. Kernel alert. This string is the priority of the message. Kernel alert is the highest priority set to specify kernel to print the message immediately. We'll discuss more about this macro in coming up sessions. To brief, when using printk, when syslogd and klogd daemons are running, the output of the printk will be appended to /var log messages. Printk is called with low priority will only be appended to /var log messages. To ensure that it prints to the console, use kernel_alert priority. If you can't understand these sentences, there is no need to worry. We'll discuss this in upcoming sessions. Coming back to our program, we have discussed about the kernel headers. Coming to the functions used in this Hello World kernel module, there are two main functions. One is hello_init and hello_exit. Function 1 hello_init is a particular function that is called when the module is loaded. Function 2, hello underscore exit. This particular function is called when module is removed. We'll see more about loading and removing the kernel modules in coming sessions. Now we have our hello.c module implemented. It's time to compile. Now save this file by pressing escape and typing :wq and enter. So your file is saved now. I will list the files in the current directory by typing ls command. We have hello.c here. We'll be creating a makefile in the same directory. Before creating a makefile for our hello world kernel module, we need to know the path of kernel build directory. For this, first we need to know the kernel version. To know the kernel version used in the PC, type uname -a command. This command displays the current Linux version used in this PC. My system has a Linux version of 2.6.32. This is the Linux version which the uname -a command displayed. Make a note of this name. With this information, we will try creating a makefile for our hello world kernel module. Open a Vim editor. To create a makefile, I'll type vim makefile. Type these lines in your makefile. This is the makefile which we are going to use for building and compiling our hello world kernel module. Let's see significance of each and every line in this makefile. These are the couple of lines which are present in our makefile now. The first line obj-m colon is equal to hello.wo. This assignment states that there is one module to be built from object file hello.wo. Some may wonder how this single line does the whole job. The kernel build system in 2.6 is designed in such a way to handle the rest of the parameters, while this obj-m command states the kernel about the module to be built from the object file. Next line is kdir. It's a kernel build directory. The directory which starts with 2632, here is the one which we noted down before creating this makefile. We got this kernel version by executing uname -a command. The third line is pwd, the current directory path. It shows the kernel about the current location of our kernel module. We'll read the current path to pw variable. Now the last line is the main makefile command which switches to your kernel build directory and invokes the command to compile the hello world kernel module present in the subdirectory. The -c option tells the make command to switch to the kernel build directory. I'm back in the Linux terminal where the makefile is implemented. I'll list the files which are present in this directory. You can see hello.c and makefile here. We have completed the fourth step of creating a makefile to compile the hello world kernel module. Now the fifth topic will be compilation and kernel object generation of hello world kernel module. Executing a makefile is very simple. You just need to type the make command. So I'll be typing make here and I'll press enter. Makefile has compiled the hello world program successfully without any warnings or errors. Let's list the files generated after compilation. I'll type ls command. We can see that our final kernel object hello.kwo is generated without any issues. So we have completed our 5 topics. Right now we have hello.kwo module. In the next session, we'll see how to load and remove this kernel module. If you like this tutorial, don't forget to give a thumbs up. To watch more videos, please subscribe Mr. Techpathy Tutorials. Thanks for watching. Goodbye for now.